Inverter.
Welcome to ClickMyProject.com. Our project title is Secure and Efficient Privacy Preserving Cipher Text Retrieval in Connected Vehicular Cloud Computing. Abstract. To collect data in an efficient manner exclusive of network congestion is a very challenging task. Propose VANET tool which provide data gathering between vehicle and RSU. We also monitor log report which is considered as an attacker file. Public key cryptography gives a security strategy to enhance the secret keys. The key exchange issue is the means by which gatherings exchange the key or data in the communication channel so that nobody else other than sender and recipient can get those. For that, we encrypt the report based on elliptical curve cryptography algorithm using the key format which is implemented by using diffie-hellman algorithm. The user can decrypt the file only if they give the correct key for the report. Retrieval of data is done by via the super peers. Data owners request for storing the file in the encrypted format to super peers. Super peers store it into the online cloud. Data searchers get the file from the super peers. Simulation results shows our proposed system achieves less consumption time and efficient cryptographic algorithms than the existing systems. Let us see the flow of our project. Our process is vehicular network with cloud computing. For that we have to register on it and log in. First the data owner have to add the encrypted file. So our process is based on the data owner, super peers and the data searcher. So these are all done by using the cloud computing. There is a cloud server side. First we have to implement this using the network side. For that we have to monitor. We use VANET simulator tool for placing the RSU vehicle and all. So we have to first place the RSU vehicle street light in that particular OSM which is downloaded from the Google Map. So we have to download any real-time OSM OpenStreetMap. According to the OpenStreetMap, it will be generated the attacker report. So from that attacker report, the data owner upload the report and encrypt it and send the generated key to the data super peers. So super peer get that data file from the data owner and store it in the online cloud. We use box cloud data server which is loaded in the online. So data server who requested the file means it will be decrypted based on the super peers request. So this will be get it from the cloud server. Let us see the output of our project. For that we have to import our coding in NetBeans IDE 8.2 as well as we have to on the WAMP server. So now I am going to run our process. The process home page is index.java. So click on run file means it will be run. So this is our first page. When we click on this means it will be move forward to the next page. So this is our RSU track as well as the cloud service. In this part we have to implement our vehicular ad hoc network. The cloud service means we have to implement the stored report that is the log file which is stored in the cloud server. In this cloud we have to use online box server. So our first process is to track the RSU. For that I am clicking this means it will be moves on to the VANET tool. So this is our VANET simulator tool. Now I am going to import our map.osm file in the edit tab. So click on this and go to our code folder which is in the D colon. So this is our OSM file, map.osm. We just imported. This will be gives our map.osm file. So now I am going to generate street light. So this is our map.osm. Now I'm going to generate our process. For that we have to enable the editing mode and set the traffic lights. First we have to generate the traffic lights. So now I'm going to add the traffic light in this place. Four traffic lights are added. Next process is to add the privacy and even for the process. Now I am going to set the vehicles, attackers and RSU. First I am going to set the roadside unit. So for each 200 meters, for that we have to set to 200. So click on this means it will be set the roadside unit for each traffic within the 200 meter. Next I am going to add the vehicles. So we have to set 20 number of vehicles for each transmission. So this is for adding the vehicles. Now I am going to add the two set of vehicles. So now the vehicles are added. So now I am going to add the attacker. For that, enabling the attacker. So add the attacker in that form. Now I am going to run this, means it will be generate the log file. For that we have to disable the mode and click simulate, means it will be simulated. So that 20 vehicles from this land, this road, this road. So we have to set 3 types of vehicles with the attackers. So the traffic light, depending upon the traffic lights, it will be react. So if green means it will be forward, move forward towards the destination. If it is another colors or red or yellow means it will be changed. This log file is stored in VANET simulator. Next the report, from the reporting we have to add the report in the data owner. So now I am going to run the next process. So cloud service. So click on this, means it will be the generated log file is displayed here when I am clicking this. So this is our date, time and the log file of the process. So go to the next step. This is our data owner encryption. So click on this, means it will be give the data owner encryption file. So now I am going to select the attacker file, so which is in detect attack.txt. So that file will be displayed here, and we have to generate the keyword. For this will be generated by using diffie hellman key exchange algorithm. So now I am going to connect the process to that super peer. So I am going to request to super peer, means run the super peer. It will get the key from that particular data owner. So now I am going to get that particular storage file. So we have to first encrypt it. So the file is encrypted. So we have to click store means which is stored in the online cloud. So we call the box server. So this is our box server. So which is in C colon and the user folder box synchronization in this VANET encrypt. So this is our encrypted file. So this is our encrypted cryptographic algorithm, which is elliptical curve cryptography. So the next process is decryption. So stored in online means it will be stored on this online process. So next I am going to decrypt it. For that we have to on the data searcher. For that we have to log in. So if you are new to the process means we have to register first. So now I am going to registering. For that we have to give any name. And the password. So the registration is done. So I'm going to give the mail ID and the password is 123. So the username and password is matched, and these are the encrypted file. The last file is ECC_1723. So we have to get the file, but it is in the encrypted format. So this is our encrypted file. So now I am going to get it from the super peers. So we have to request to super peer. So I am going to now click the super peer description. So I am going to get the key. So this is our 1723 is requested from the client. Now I am going to give the key for that particular using the VANET process. So for that going to that so this is our key. So 1723 have key is this one. So now I'm going to give that key means it will be allowed to decrypt. Now I am going to send the file to the user. So decrypt means it will be decrypted here. So date and the file is decrypted. Any file is decrypted by using that diffie hellman. The decryption and encryption is done based on the private and public key, which is produced from elliptical curve cryptographic algorithm. Thank you for watching.